Okay, so yes, there's a lot of enthusiasm for this meetup, and I've been waiting a couple months here. So I'm very excited that Evan is able to make time to come talk to our group. So Evan is a director and lead data scientist at the Rockefeller Foundation, and in that role, he manages data science funding and advises on technical projects. Prior to joining Rockefeller, Evan led research analytics at Media Development Investment Fund, managed technology programs for IREX across the Middle East, and he was a Fulbright Fellow in Azerbaijan. He's a graduate of Hiram College and Columbia University's Quantitative Methods program. So welcome, Evan Tachovsky, to the Cleveland R user group, and we're all very excited for your talk.
Awesome. Well, thank you for having me, John, and thanks for reaching out. I know I don't know if I have enough to show for my Twitter usage, as you mentioned earlier, but I'm glad you've gotten something out of it, and I'm so excited to talk with you all today. So, as you mentioned, my name's Evan Tachovsky. That sort of long bio basically just means I work for philanthropy and tend to advise more on funding of data science projects, or in our various scientific efforts, new methods. And I'm more of a spatial statistician by training, and thus, like to keep up on the side and make sure that I'm doing things that I'm passionate about, keeping up with tooling. And one of the really exciting things about R for me over the past couple of years has been the spatial toolkit, right? So a lot of these tools that I'll tell you about today, we'll kind of walk through, are things that didn't exist, even when I started the project. So you may even see, like, depending on which, where in the sort of year when I was doing these maps, it came, there may be different syntax, maybe different packages, maybe some things there. But it's such a dynamic and fast moving area. It's for me, just a really great way to learn R and to stay with it, right? For me, day job, I end up used to code about 50% of the time, and now probably about 20% of the time. So I need that side project just to keep going. But yeah, super excited to talk today, and we'll walk through. So what you can expect today, basically, we're going to do a very, very quick introduction to a couple of geospatial concepts that might be useful if you haven't dove in here before. So we're not going to go super in detail, but just some of the things you'll run into, you'll hear me say, some of that vocabulary. Then we're going to talk a little bit about the tooling. I'll introduce you quickly to some of the tools I'm using in R, and then a few of the others that may be helpful on your journey as well. And then we'll talk a little bit about just the process of doing a book. It was my first time, obviously, and kind of a unique project. So there's a little bit of a different workflow when you're going from ideas to prototyping, to finding data sources, to doing that whole process. So kind of walk through that, since I think that in between prototype and finding data sources is really where I spent most of my time. And I think you'll see that represented when we get to the charts. Most of the code can be represented in basically a screen, but there may be 3 months worth of like reaching out to people, following things, tracing old maps, finding old zip code, a whole bunch of stuff that went into it there, and really excited to dive into that and hopefully make that relatively clear. And then finally, we'll go into a couple maps. I think I pulled out 4, depending on how time goes, and walk through just the map and then some of the code behind it. Unfortunately, I'm not on my personal machine today, so I won't be able to really run the code. Ran into a bit of an environment problem, as we will see. Many geospatial packages rely on a couple underlying packages that, if you haven't spent a little time tweaking your environment, may not compile correctly. And so I will show you the code. You're going to have to take my word for it that it runs, but it ran well enough to get a map together to put in a book. So I will think if it's worth it. And I do hope to, over the holidays, it's kind of always my ambition to put a little bit more of this online on GitHub. I have a couple things on there right now, but always want to kind of get more of this out there. So without further ado, I'll share my screen and get started. Great. And can I just get a quick thumbs up from somebody if you're seeing the front of this book? Okay, great. Awesome. So first I should say, nothing to say today is really the views of my employer at all. This is my side project, and I'm excited to have it be that. When we started Cleveland in 50 Maps, I'm from the Cleveland area. I was born and raised in Bedford, Ohio, and spent most of my early days kind of driving around this area and exploring the geography of it very experientially, right? So I drive down South Woodland Avenue from Shaker into Buckeye, and really wonder, like, why does this neighborhood, as a 16-year-old kid, like, why does this neighborhood change so dramatically? The types of stores that are there changes, the types of, how many churches there are in each neighborhood changes, et cetera. And so, had always been fascinated by Cleveland, had always had, opportunities to explore it in these different ways. I was involved in music when I was a kid, and really got around to different parts of the city and saw, a million different house shows in a million different neighborhoods and things like that. And so, it's always been on my mind that when I sort of acquired this, the spatial analytics skill set later in life, that I wanted to do a Cleveland Maps project. And I was really lucky enough to meet Ann Trubeck and the folks at Belt Mag And at the time, we'd done a couple projects for their online magazine. And Anne was gracious enough to offer, if you want to pull it together, we'd be happy to publish a book of maps. And they were able to provide the resources. So Dan Chrisman is an incredible editor, and David Wills is an incredible graphic designer. And those folks really made this project come together. Without them, it wouldn't be possible. So we're going to dive right in. As far as this geospatial primer, I think one of the two big things to understand about geospatial is you're going to end up working with a lot of different file types. And those file types are going to be really suboptimal. They're going to be, things that have, like, you've never heard of before in normal life. These are some of the more germane ones, but in a sort of geospatial project, I always run into a new file type. And the way to think about it roughly is there are three categories, right? So you have first vector files. And in that case, the file is storing a map. It's storing an equation that tells the computer how to draw a shape. You have raster files, which are basically pixels on a grid. And each of those pixels can have a value, it can have a numerical value, and often it has some sort of like scale value. And then we have tabular data, which is what we're often used to. So that can be your CSV file, your Excel file, etc. And any one project, as you'll see, probably uses 3 to 4 of these, and often you're moving between different types. Where we're going is GeoJSON, GeoTIFF, these sort of optimized file types for geographic work. But where we are is, for any project, you run into those lovely, nice file types probably 20% of the time. And the rest of the time you're spent with, say, shapefiles, this .shp. Shapefile is actually a collection of files, each one with its own sort of role, comes out of the Esri universe. It used to be kind of fully a proprietary data type. Now it's kind of a quasi-proprietary data type. Not really great stuff, and a lot of things that can go wrong. And so, if you're going to be doing geospatial work, you're going to get used to different file types, manipulating them, switching between them, etc. The second thing to think about is projections. So as this little chart shows, the world is round, unlike maybe the view of some ex-Cleveland Cavalier basketball players. And our problem when we're making maps that go in, say, a book, is we're literally trying to flatten out something that's round into something that's flat. And there are a number of different ways to do this. That each one distorts something, or we lose some sort of information in that. And over the years, people have developed different systems for doing this projection that minimize that distortion, or account for it in a way that's useful for the type of analysis that's being performed. And so you will, when you find a geospatial data file, it will either have a projection coming with it, or it will not have a projection. You'll have to add a projection to tell the computer about how to make that file flat. And a lot of sort of the initial challenges with kind of getting things together, or what you'll see is just reconciling that and aligning around a single type of projection, or a single way of taking our round world and then flattening it out and making it overlap with others. As far as tools in R, for this book used about 90% R. So, I'd say it would be possible to make every map in R 100%. And I'll go a little bit more into the packages and things there, and then 10% other. And I think these are tools that I'd use for some efficiency, working on a deadline, working on with a lot of maps to make. Sometimes it's a little easier to pull out some of these other tools. But as far as the R, 3 big packages that I rely on heavily. The first is the SF package, or the simple feature package. And without going too much into what's going behind the scenes, SF gives you the power to work geospatially, but to think like you're manipulating tabular data. So it very much fits in like a tidyverse syntax. Everything's super pipeable. The sort of functions are named in really, really reliable ways and perform the way you think. It's organized well. It's relatively efficient. The underlying libraries determine a lot of that and how you have things set up. But it's certainly efficient enough to do the type of work I'm doing here. I'm not sure if I'd put it into production somewhere, but it's great for this type of rapid iteration around different maps. It is not a super old file, but not a new file, or sorry, not a new package anymore. Probably I forget exactly how old, but it sort of succeeded the SP library, which was kind of the precursor. And you'll see a little bit, I jump back and forth between the two. There's some things that are still not quite possible to do in SF that are possible in SP, but really spent the most of my time and better for it in the SF universe. Well-documented package, has great support from a team called R-Spatial. that maintains a lot of these different groups. And I would fully expect it to be something that's worth learning, worth growing in if you want to go in this area. And then two old stalwarts of this type of work, the tidyverse and all of its sort of components, dplyr, etc. And then ggplot2, which is where we're making every map in this book in some form. Now then, to quickly touch on the other tools, we have QGIS. QGIS is sort of an open source version of Esri. It has a GUI, and it allows you to do some things that otherwise wouldn't be possible. I've since actually learned how to do some of them in R, which is kind of fun. But things like taking old maps and tracing an outline of an area, and then reprojecting that and exporting it as a GeoTIFF or GeoJSON, depending on what you're doing. And used it for a lot of those functions where it's just like, I have to get in there and trace something or manipulate something in a very kind of hands-on way. There isn't an immediate, way to do that in R without a lot of iteration and testing. And so it's probably just easier for me to go in there and manipulate the thing by hand, basically. And then the other tool that I used a lot in this project is something called mapshaper.org. This is really useful if, like me, you're kind of doing this on the side in the evenings and you don't want to really spin up any cloud computing resources. This allows you to deal with larger files, cut them down in a number of different ways. I mean, you could mostly think about it, if you imagine you have a really rough edge, it allows you to simplify that edge, fewer lines, making up that edge. And so the file type gets smaller and allows you to shrink things or abstract large files in really useful ways, do sort of rough abstraction. For example, one of the data sets I use a lot is this Microsoft open data set where they have building outlines for every building in the United States. That comes to you as an absolutely massive file to begin with. You can start by subsetting by states, but then really you want to trace down to a county or a part of a county. And so I could quickly kind of hack that apart. Use MapShaper, has both a command line interface and then a GUI to manipulate. But that helps me do things that would be kind of overnight jobs on a desktop in less than a minute, right? And so using that just so I don't have to go through the complexity of building any sort of cloud environment. As far as the workflow for creating these maps, we started with a set of themes, and these are sort of laid out with the generosity of our editorial folks who actually have more of a way with words. If I did, it would probably be like geography, transportation, demographics, right? But they gave us some focus here. So lay of the land really focuses on the topography, the way the city is laid out, the sort of natural stuff below our feet that we've built on, the rivers, the lake, the various elevations, things like that. And we try to think of those both in their literal form, but then also make sure that when we're laying out some of the basic topography, it connects with maps later in the book, right? So you can see how all of a sudden you see certain communities are situated on hills or situated on one side of a river or another, situated close to the river, etc. Getting around about transportation, the way transportation I think is very much defines a lot of Cleveland, and changes in transportation over time have been actually pretty dramatic when we look back to it. Community of Clevelanders is our demographic section. Tried to think of both demographics in terms of your normal census data, but then also things that might not be captured there that we might be able to capture somewhere else. And then institutions, Cleveland's institutions, from the art museum to our sports teams to our leading foundations to certain high schools. Cleveland is a place built on a lot of institutions and continuity in those institutions. So want to make them a part of the book. And then we ended up with something called Looking Ahead, which was how do we start making maps about the future of Cleveland and what is the potential, what is the potential peril as well for Cleveland's future. Those sort of themes, once we kind of aligned around those, kicked them around enough to understand what were we going to be looking at from, I mean, for Anne, right, being a publisher, she wants to know something about what this ultimate thing is going to be done before I produce, 50 maps and spend a year working on this. That went into as many things do, a spreadsheet where we had, I think we ended up with over 150 ideas. A lot of these were sourced by, that team that's on the front of this book. Reached out to a couple of friends, relatives, folks who had a good sense for what would be interesting. And came to about 150 of those, of which we subset down to about 50 of those. And that process really subsetted by, honestly, where we could get data and where it was feasible to produce data on the timelines we were working. We're, really great, honored to have the treasurer of Cuyahoga County GIS. That team It does great work, and there's a lot of great data there available. Second group that we relied on a lot is Cleveland Public Library. So this is both for, they have an incredible map room if you haven't visited. One day when things are back open, definitely stop by. And that's both for inspiration and then also a lot of the historical data sources that we ended up using. A lot of federal GIS sources, so everything from census files to various environmental agencies, et cetera. And then we still had to do a fair amount of public data scraping and extracting data from PDFs. So things like an annual report for the metro parks was the only place where we could find attendance data for the metro parks. And that ends up being where we spend a lot of our time and a lot of frustration, and where maybe some ideas we're really excited about become impossible, and we kind of cross them off this spreadsheet on the left. Sorry. Moving through, once we've done this data sourcing and we have a sense for something, it's possible or it's reasonable to expect with some effort we could get it together, start building prototypes. And these are sort of map sketches or things that are good enough to give us a way to talk about them, right? So say, okay, let's put these 4 maps in a row. Does that make sense in an editorial workflow? Do these sort of correspond, or does it feel like we're doing totally different types of projects within one sort of thing? And I think this is where we started really communicating about the design and look of the book, is when you hit those first prototypes. Very circular. We got to go back and forth between this prototype works with these data sets or it doesn't. We keep coming back to this process. And then once we're done with prototyping, we get to a working draft. So this is a solid chart that has sort of its final structure. So it has its final sort of geometry, right? We know it's a choropleth map. We know it's a dot density plot, and it looks like this, and it's shaped like that. And then we can go through an editorial process where, critically important for a book like this, titles, the text that goes along with it, and fact checking, right? So if we're going to go through and spend the time to do this work, we want to make sure that those things are tight and it isn't just, like a slide deck that I could do for you all here. And that's where the, the value of all of our other collaborators really came in. So once we get done with all of that, the final thing I produce in R is an SVG, and that sort of vector graphic can be used by our designer and put in InDesign, positioned, do final tweaks, and basically create a book layout. And so this whole process from initial ideation to publishing took a little over a year. I think we started in 2018, the fall of 2018, and then started producing maps really early in 2019, and then had a final version by early summer, and then went through that process of fact checking, text, all of that throughout the summer, and published last October. So yeah, that is roughly the process of how we do this. If you want to learn more and actually publish a book called So You Want to Publish a Book, and there's a whole section on basically the economics of publishing this book, where she goes into detail about how she as a publisher thinks about a book like this, relatively in the grand scheme of things, a niche book, but with an interested audience. And so you can definitely read through that and see how a publisher thinks about this project, in addition to how a cartographer myself thinks about this project. Awesome. So I'll take a second here. Now we're going to go on to maps and the code that underlies them. And here, as I said, I won't be able to run it live, but hopefully we'll be able to kind of walk through, and I can point out some features and some ways I'm thinking about structuring these projects and the way I'm thinking about manipulating the data. I chose 4 maps from the book, some of which may be accessible online already, some of which not. So hopefully this is an interesting mix. Tried to get also a mix of maps that are I guess I would say complex, and some that are simpler. And this is not at all sort of a, it's not complex or not better here, right? So the simple map can actually be quite powerful and quite good. But where we're doing something that's, so some of these maps are just representing another shape in a different context, right? So if we have an outline of something, putting it in the context of a city, allows us to do it. And then these are manipulating in different ways. So cartograms, for example, actually stretching spatial shapes, or dot density maps representing each individual as a single dot within a polygon, et cetera. And so try to get a mix of some relatively straightforward ones, and then some ones that are a little more adventuresome. And I'm also going to be, let's see if I do this here. I'm going to be switching back and forth between the maps on the screen and then the code over here. So I hope that doesn't give anyone any whiplash, and I hope we're able to kind of make that work. But if it gets too chippy, let me know, and I'm happy to just kind of stick on one side. For right now, we'll move on to the first map. So one of the underlying themes of the book, right, was making invisible things about Cleveland visible, right? And I think probably the most the most obvious and on the nose version of this was mapping out a salt mine that's under Lake Erie. This is for those who aren't familiar, it's a Cargill mine. It's absolutely massive. You'll see later you can calculate there's a little dot right there. That's First Energy Stadium. Fits 167 First Energies by area, and has grown significantly since this version of this map was done. So to get this, I knew that this mine existed. I actually had a family member who had worked in the mine, but I was unable to get sort of current boundaries. And so this is one where like we knew we wanted to do the map. We thought we wouldn't be able to do it, but ultimately we're able to find an outline, more of an architectural drawing that had been put into the collection at the Cleveland Public Library, which is on the right. And you can see that file there is a little bit more sketchy. You can see it's almost, I would not be surprised if this was actually hand drafted by a draftsman at some point or something like that in its journey. It's a little bit old, but it allows us to at least start telling the story of this massive salt mine that's out in front of us every time we look at the lake. And so the process basically was, we spent most of the time on this simply tracing these outlines and getting these data into a spatial format, right, that we could actually use. And then we then made decisions around what other context we wanted to add, right? So the sort of style of the book is relatively minimal. We try to make, sort of one map be kind of one story, but then folks can kind of bring together, in their own experience, kind of layer them over each other, talk about it. And so we don't do too much complexity, but we want some context. So adding things like, for example, the stadium to make sure we can point to that or highlight in the text, and making sure we have space for this sort of, the text up there that describes what we're doing. So to now switch back over, we will get back over to the data here. So what we're doing from a code perspective is load up our three, trusty libraries.
Hey, Evan?
So, yes.
Could you zoom in a little bit?
Sure. I'm going to see if I can do that. How's that?
Much better.
Is that good? Okay, great. So we load up our three trusty libraries here. One I didn't introduce called MapView. So, say for a project like this where you're trying to produce a lot of something, the thing I'm trying to optimize is basically speed of iteration. So it's a lot better if I can get a really rough and dirty map that tells me I don't want to pursue that map, or it tells me if there's something, good to go there. And so for that, I use this MapView library. It's a relatively simple library. I think it has more than one function, but the main function is MapView. And it basically allows you to take a spatial object and visualize it really quickly, really efficiently. And so you can kind of go through that process. The other two are kind of workhorses, SF and the tidyverse. So we go down here, the first part, our file here, we're going to be importing and cleaning data. We're going to be setting up a little bit of this mapping canvas. And we're going to be going through a couple manipulation steps to get to our final data. So I'll walk through that. And then down here, we're making the map, right? We're basically using a ggplot object, building layers in an order so that it comes out like our final map looks. And then we're writing that out in two forms. So our PNG, that's what we're using just for the editorial process. So we can quickly slap it into a PowerPoint deck and kind of, add the text and do things like that. And the SVG that goes to the designer who can use it for the final version here. So if we go back up a little bit, the first part here, we're going to start by defining a bit of a canvas. So if you remember over here, we're working in just a certain part of the city, right? This is downtown, near West Side, not even East Side, so basically just downtown and near West Side. And we want to kind of cut almost all of our files to that boundary box. And so first we're going to define a boundary box, this is object BB. We're going to use that throughout. You remember earlier when I talked about projections, we're going to be doing that right over here. So we're setting the projection to something that's called WGS84, also known as EPSG 4326. Your best, if you're dipping your toe in these wires, it's best to pick one and stick with it. And then, over time, you'll get a more sophistication about why you might want to use a projection for one task over another. But really, a bit of an unfortunate reality of basically working with spatial data. But we're setting that, so that bounding box is now a spatial object that we can use to kind of subset or crop is kind of the verb we're using down here, right? So we can read in now our Cargill boundary data, which is what we traced using QGIS. and export it as a GeoJSON file that's really nice and light now. That sort of image from before was absolutely massive. It was almost a half gig, the original image, because we used a high resolution scanner to do it. And so now we're cooking with gas to get a nice efficient small GeoJSON file, reading that as the raw file. And then if you'll remember, there's a bit of a cutout. So I don't actually know why, but there's an area they have not explored here in the middle. And so we actually need to bring that in as a separate file and then essentially use this function, sterase. We're doing it, I'm writing this function by hand. Since I wrote this code originally, sterase is now actually an official function and is, I didn't write it, so it cannot claim any, but is gone from something that people could kind of cobble together from these other functions to something that is part of the SF package. So we got that function, takes 2 arguments. The first is the file, and then what we want to knock out of that file, and allows us to simply erase that pretty quickly. We use that function again later for some other tasks as well. So then we're going to bring in all this contextual data. And so things like the water, the river here, the boundary of the river, things like the buildings you're seeing, the shoreline, all these different files are going to be brought in together to kind of give us a little bit of this context. Railroads, you can see those here. And we're going to be bringing all those in, and once again, transforming if it's not in the right coordinate system, and then cropping to our bounding box so we only have what we need. Final one here, Cuyahoga County buildings. This is a pretty heavy file. It's the outline of every building in Cuyahoga County. And so we bring that in and crop that. Gets a lot easier to use. Once again, that's from Microsoft's 2018 release of building footprints for every, I think all 56 states and territories. I may just be states, but I check on that. But a really useful file that I use throughout this project. Then once we get those here, I'm doing this in a pretty simple way, where each layer is basically a geom SF object that takes a data set and then some arguments about the color or the fill or whatever we want here. And keeping this very, very simple. And one of the things I found here is when you're working on a project with a lot of outputs, there's a temptation to start tinkering on every single possible chart. And I myself love to do that. I think there's nothing more satisfying than turning your brain off and slightly tweaking colors of gray. But what I did for efficiency on this to kind of get through the project was just picked a set of colors and kind of stuck with them through my design process. And these were colors that are pretty close to what we use at the end. We ended up using slightly different colors because of what's required from printing the book in that perspective. But doing this really allowed sort of our designer to just quickly make holistic edits instead of rethinking our entire color scheme or how we're using colors. And then you'll also see, and this is one of our sort of stated goals that I talked about with the designer along the way, is we don't use too many colors. I think the most colors we use in any one map is 4, and we tried to keep it even less. If you'll give me different tones of gray as one color there, we tried to keep it very, very light on colors and emphasize color where emphasis is, and not too much in the way of complexity there. And that's one for limitations on printing. So it can, if you have every shade of the rainbow, that's a really more expensive printing cost. And then 2, just for clarity and the sort of style and the aesthetic we were going forward, it's relatively clean. It's not so much like an atlas or a road atlas you might find. It's not quite like a fully kind of artsy chart graph, but it's a little closer to that in the sort of more minimal way. So we build each of these layers. And then interesting is I think this is no longer necessary, but at the end here, sometimes with SF, you would get these, it would give you I think they're called granicules. So those, if you imagine like a globe, those lines that go down, those actually stick through in the SF objects, and you have to set this datum to NA to get rid of that. So this is the end of what I would call sort of a relatively simple map in the Cleveland and 50 Maps book. At the end, we've done this for a little bit of a talk, just wanted to calculate how many first energy stadiums. To do that, we took that buildings file. Here I'm using the map view function just to get that visualized. And map view is great because it basically gives you a hover over of any sort of metadata for each object. And so you can very quickly, basically be like, wait, what is that object again? Oh, okay. So I can literally mouse over the stadium, find its object ID, which otherwise I'd be completely lost and kind of, iterating through. It doesn't have the name First Energy Stadium, but can pluck that out, isolate that, get to calculate the area for that, calculate the area for my mine, and then you know, calculate how many, roughly, I don't think we actually put this in the book, but roughly how many first energy stadiums would fit in that mine. So we'll go back over. So from one that's, you know, relatively simple in terms of it's just a boundary with some contextual data, to one that's a little bit more, I guess I'd say playing with the form, right? So one we're going to use here, this is a dot density map where each of these dots represents 30 people. You see these a lot with kind of other types of population and demographic maps. And we're doing it, normally the way they do it is, you know, you get a geographic boundary, a state, a city, a county, and then you randomly allocate those dots within that polygon with the density of people kind of underlying it. And it has this sort of attractive characteristic of being very intelligible. So, you know, one person is kind of like a nice way to think about it. It helps people. And we find, at least I've found, that people actually, so lay people actually have a hard time with chloroplast maps sometimes. And this is somewhat of a more obvious way to do it as opposed to doing like color scales. So it has some advantages there, but it can be really fraught because there's a lot of interpretation. And, you know, what we're doing here is we'll play. So each dot could represent 1,000 people or 100 people, and then it allocates them kind of randomly throughout a geography. And so there can be some real challenges there and can kind of mislead you. We took that form and said, okay, well, if we could do like randomly allocating dots to a dot density map within any polygon, why not use the shape of a stadium? And so we wanted to look at how has Cleveland Indians attendance changed over since 1994 when the team moved to what was at the time Jacobs Field, and then went through a name change, became Progressive Field all the way through. And, you know, as we see, you know, for anyone who was a Cleveland sports fan in the 90s, you can remember the years 96, 97, 98, where sellouts, right? So the entire stadium was sold out even before the, you know, before the season started. You know, incredible teams, almost won the World Series if Jose Mesa didn't screw that up, etc. And so it tells part of that story of the Cleveland Indians attendance, and then some of these darker periods. So 2003, when there's a real drop off in attendance. And we see that, you know, despite the team getting better in 2017, 2018, and then in recent years, never really regained that full sort of attendance, right? And this is just a little bit more of an impressionistic way to tell this story, and something that we were kind of looking forward to have a balance of maps that were very literal and spatial, and maps that were a little bit more interpretistic. So this one is also a little more complex in terms of how we generate those data, right? Because we're going to have to do a process where we're going to generate a bunch of random points, et cetera. And so walk through that. Once again, very consistent on just trying to use, you know, as few libraries as we can, just SF and tidyverse. So we're going to start by reading in this polygon, this boundary for Progressive Field. Apologies for my own internal joke of calling it Jacobs Field in my code here, and then Progressive Field in the file. I will, of course, always know it as Jacobs Field for being a kid around that time, etc. And then we're going to read in an attendance file that comes from the Baseball Almanac. So the Baseball Almanac gives us attendance data. I believe in this case we were using the average season attendance. Yeah, I could go back and check, but for the since 1994, and allows us to cover two different eras, the Jacobs Field era, Progressive era. Do some basic manipulation here. This right here is where we're going to iterate a lot, right? So when we're making this map, I'm going back and changing this number right here. So how many people does one dot represent? You know, went through a lot of different versions of this and ended up at about 30. So don't want to, you know, in a dream world, we'd have one person, one dot. But, you know, in the map, we have to abstract somewhat, and, you know, things like 1,000 people per dot, that gets pretty sparse and doesn't feel real. It doesn't feel like a crowded stadium sort of in our visualization. And then, you know, you go down to 5 and it just looks like a blob. Everything kind of looks the same because all those dots kind of overlap. So move on to building this dot density file, right? Or this data set, right? And so we have first a function which does this for 1 year, and a year basically taking like the geographic file and then the size of the attendance for that year on average. And it allows us to take, basically create random points for all those data, for how many ever data we have in the data set, and spit that back out. And then we're gonna take, that function takes 2 arguments, the number of attendance and then the year, because we wanna map it using map to _df. across a combination of different attendance numbers in different years. And then we want to return a data frame. In this case, it'll be a spatial data frame with type SF. But we want to do that really cleanly. And this is, for my money, why, for any sort of daily driver data manipulation, I come back to R, and increasingly come back to functional programming is like the way I sort of think about data manipulation, because the ability to map these functions across different types of data sets or different types of inputs is incredibly powerful and really abstracts a lot of other things, and it allows me just kind of muscle through problems very quickly, get results, and move forward. Down here, we're going to merge in the original data set, and it's great because we can join it right back up because we have a field there to unify on, and allows us to have some other contextual data that came from the baseball almanac file originally. So once we've got that file, this file is basically a really long list of individual points. So each of those points you see in this chart is a row in this file. And it has a coordinate, so it has an X and a Y. And we're going to first plot those points, and then we're going to facet by year. And that'll give us this nice, relatively appealing geographic layout where it's nice and square, and we have a lot of repetition. And even for folks who aren't going to spend much time with the graph, like it's somewhat of like a, you could put it on the wall in your bathroom, and people are like, huh, interesting. That sort of design element, faceting is great for that. Once again, we clear out any sort of other styling, so we just get the geometries. We don't want any other sort of annotation, anything like that, because we're going to do all that later. And then finally, we're going to read it out or write it out as a PNG and our SVG. And that goes off to our designer, and then he can form the sort of final colors. In this case, I think the final colors are really close. So this coral color and this blue are what I was using in prototyping and what we ended up using as part of the color palette in production. All right, so I'm going, we've got two more here. Cognizant of time and wanting to leave time for questions, but I think we should be able to get through these two, and then we can double back on anything. Or if anyone else has other questions or seen other maps floating around that they want to ask about, happy to talk about those. So on a scale from relatively simple map types to complex, this one's a little bit more complex. It's a cartogram, right? So what we're doing is taking a geometry, and then we're manipulating, or we're kind of bulging it out or shrinking it in based on some value in that data set. And the value in that data set here is attendance in the metro park. So on the left, you see pretty normal, the emerald necklace, the amazing park system that really allows Clevelanders to have access to some beautiful parks all around the area. And we'll get into this a little bit later, but if you look very closely, you'll see that actually instead of the raw boundary, I've taken the sort of raw boundary and converted it into a bunch of hexagons, right? So these are actually made up of little points that are, if we zoomed in, they're actually, oh, maybe I can't actually zoom in. Let's do that. So you can see they're actually hexagons here. And we did that, I did that for some reasons that we'll get into later in the code. It's a little easier to manipulate when we're making cartograms, but still allows us to keep a very literal boundary of the metro parks. This isn't sort of distorting it too much. The parks really line up with their actual location on a map. They're not much bigger, not much smaller. And then what we do on the right is we're actually going to distort them to say something about which metro parks get the most attendance. And you'll see here that parks on the west side, we zoom in again, are starting to bulge out, right? So indicating that there's larger attendance per square foot. And then parks on the right are shrinking in on the east side. And I grew up, going to these parks right over in this area, are shrinking in. There's less attendance, you might imagine. Somewhat obviously, the ones downtown get a lot of attendance, but those over here on the west side, Rocky River, those sorts of parks get a lot of attendance, and it was a really interesting pattern when we were able to pull out the attendance data. Interestingly, and I don't know if anyone who either works with or affiliated with the metro parks is on the call or in the community, but I was interested in that these data are actually really hard to get. We tried to update, tried to email some folks over there, but really the only data we could get for this was from 2015 when they did actually publish their metric. Visitor occasions, as far as I can tell, is basically visitors, and each unique time they come to a park. So there can be multiple, like one person can come twice, but roughly that metric seems to be the way they account for their attendance. So if we jump back over to the code, we're going to get a little bit more complex here with our libraries. We're going to add this cartogram library, which is an older library that relies on SP under the hood. And so we will see kind of jumping back and forth between different approaches and different sort of philosophies in manipulating spatial data. And you'll probably get a little bit of a taste for why working with SF is just a step change improvement in our ability to manipulate. And then we're going to use read Excel for some Excel-based data that we're going to read in. So once again, we're going to start with some context data. So this chart, we want to have that water, we want to have that shoreline to basically frame out our data set to give people some sense for where they're at in the world. And then we want to also read in the Cuyahoga County boundary, so we get that nice crisp water edge, and that is real and literal. And then we're going to read in our Metro Parks data, which is this attendance file that we've scraped and cleaned from a PDF report of an annual meeting that they had online. And then we're going to use the reservation shapefile from the Metro Parks. Once again, you'll see for a fair amount of these, we actually have to transform into a new coordinate system. But at the end of the day, it's all going to line up, and we're going to have the ability to kind of overlay them without worrying too much about that downstream. Then finally, you're going to see this empty hex grid, which is what we'd built in QGIS, and that's basically we took this reservation file, or I took this reservation file, read it in, and then basically said, okay, give me a layer of hexagons over that, and then drop every hexagon that doesn't overlap with the underlying file, and you get that nice sort of like hexagon map of those areas, and you can manipulate them sort of independently, which we'll be doing later in the file here. So there's a bit of a cleaning that we had to do to the attendance data. We had, let's see, done some of that in the process of scraping it, but there were basically different types of, what was the name of the metric again? Visitor occasions, or different types of visitor occasions. So someone could come to play golf, someone could come for a drive-in or a walk-in or a hike, etc. And we had to just sum those up so that we get one number for attendance throughout the year. And then we had to convert that to by square foot so that we could visualize this across. And then we had to join. And this is like the incredible power of SF right here is, so we had our hex data right here. If you can imagine, each of those hexagons kind of gets a row in your sheet, but they all have a common ID. And so there's maybe, say, 50 hexagons that make up Rocky River Reservation, but we can join data against them because they're all part of Rocky River Reservation. And so each of those can have, we can basically join in that Metro Parks table, and it can be really nice and clean. And then when we tell the cartogram function to, okay, distort this, it can distort all of those hexagons nice and equally, and you get that nice kind of bulging effect. Takes that we were looking for. So to do that part of the work, we do have to engage with SP. Since cartogram handles SP better, there are ways to use it with SF, and probably has improved significantly since I did these. But at the time, had to basically take the file. We're starting with SF object here, and coming out the end through a series of steps. We have to first convert it into an SP spatial file, which is a certain basically type, and then we have to go to our spatial polygons data frame, which is another type, and that's the type we need for our cartograms function. Then cartogram function, relatively simple. We're going to give it that file. We're going to give it what to wait on, what to distort on, and then we're going to tell it how many times we want it to iterate through the algorithm to kind of stretch this out and place each of those so they don't overlap. Thankfully, it's pretty easy to get things back. We just take ST as SF, and we're back into an SF type file. And we can do this again. I think if I'm looking at this, I guess I was probably deciding between doing pure attendance and attendance per square foot as we're doing the final map. And then we come out with basically the ability to make these two maps. So the first one are our hexagons that are just in the shape of the Metro Parks, and then our hexagons that are stretched to tell us something about attendance size. I'm going to stop here for a second because I did see something pop up, a question. See if I can get that there. So Tim writes, ran across this data the other day, thought it would be useful for making data to practice mapping with. Excellent. Yeah, you know, we could probably discuss this in the chat, but you know, one of the incredibly thin silver linings of COVID is there has been a lot of opportunities for data visualization, and data visualization has an impact on public health and people's opinions about how things are working. So yeah, I'm, you know, if people are at home right now, and encouraging, maybe outside this call, but people to start learning for the first time to make maps, to make visualizations. It's a really rich time to do that, and you can, you know, we've seen people who really have started quantitative projects at the start of the sort of crisis and become actually like very important people in terms of our understanding of the crisis. So definitely a great time to start doing spatial analysis, and you know, a time where that work can have an impact. So I'll close that out and we'll get back to that in a bit. All right, so we'll run through one more map. This is back on the simpler side, where we're taking a kind of geometry and we're just exploiting something about the way it works to create something that's visually appealing and that tells us something somewhat obvious, but also kind of fun about how Cleveland is structured and run. And this map, which I'll main screen so we don't have to squint, it's actually a series of 4 maps showing avenues, streets, boulevards, and roads in Cleveland. And the really interesting thing is, you know, not every city takes this approach to framing out design, where they have, you know, avenues are everything that runs east-west, streets north-south, roads are kind of diagonals that link common destinations across, and then boulevards are these sort of scenic routes. And you can see each of those. I imagine you could probably pick out one from your experience that you could probably see on the boulevards and then the roads, and then of course plenty of streets and avenues in Cleveland. But the thing that always struck me was when the city planners decided to do this in Cleveland. Cleveland is this kind of really wonky shape, and kind of always has been. It's never been like a, you know, an Indianapolis or a Washington D.C. where, you know, a grid would make a whole ton of sense, because it's, you know, it's basically this sort of kind of a hacked off square in some case, or it is roughly a square. And so, you know, I always thought it almost kind of whimsical that city planners were like, yeah, let's do this. Like, let's make this try to be a sort of grid, a grid town, right? And that leads to this like very messy, I almost describe it as like a barcode, right, of the city, where you can look at these, there are areas of the city that do have this real dense like street where it's like, you know, if you walk street to street, you'll see the numbers go right up, and others it'll jump, you know, from one block to the next, and you'll never encounter a street again. And it's pretty maddening, I imagine, for people who navigating pre Waze or pre Google Maps. So a bit of a fun one, and relatively simple to produce, and you know, allowed to do that. As far as how we visualize this, you know, this is a straightforward application of the Cuyahoga County open data portal data from the GIS team. So we're just gonna once again load up the 2 packages we're gonna use for everything here, and then we're gonna read, you know, basically read in our Cuyahoga County munis. That's sort of our background, that sort of shape of Cleveland file that we have. We're gonna drop down just to Cleveland. We, you know, could of course include others, but different cities around Cleveland actually use different street naming protocols, and some things actually change to that. Then we're gonna read in this roads file also from Cuyahoga County, and we're gonna make sure we're just gonna intersect that. So we're just keeping the parts of roads that flow through Cleveland. And if they are longer roads that say go out and become state routes or something like that, we're just chopping it off at Cleveland's boundaries so we get that nice structure. Then we're gonna write a function that is actually really simple and maybe a little bit over the top. But one interesting thing about Cleveland is when we think about these designations, so, you know, we ended up using streets, avenues, roads, and boulevards. There are actually 31 different designations for types of roads in Cleveland. And so, you know, at the beginning of this project, I wasn't quite sure, and I wanted to be able to iterate through a lot of these and kind of compare and see which ones might fit together nicely, which ones were kind of interesting to show together. And so basically wrote a function that allows us to, you know, give a list of different types and then return those files and write them out so we can look at them and go from there. And so that is basically what this little helper function does. And then we just map it over combinations. We map it over all of them at one point here, and then we pulled out the ones we want and came back and just did streets, avenues, roads, and boulevards. So it's relatively straightforward. I think once again, going back to the choice of SF and how it allows us to work spatially, but think very tabularly. I think a lot of the functions and types of code, this doesn't look, even if you've never done, lick of spatial analysis before, you can read this, you can kind of walk through and understand the functions are named very well. They give you a lot of information about what's going on. The syntax is relatively common, and you don't have to kind of worry about learning too much on that side to kind of dip your feet in. You'll save that energy for learning all the horrible file types that exist in spatial data around the horn. So with that, I'm going to jump back over to this and maybe stop sharing my screen and jump back in with you all and take any questions, comments. We can definitely jump into these maps or others, and we'll go from there. Thank you.
Thanks so much, Evan. That was a great talk. Tons of R and Cleveland. I learned a lot about mapping and in the region. I got to remember finally 90s Indians games. I was contributed to some of those dots. So
yeah. Would have been awkward if I did like Milwaukee or something, wouldn't it? That would have been weird.
Yeah, that would have been weird. So yeah, with that, let's open up to questions. What questions people have?
Hi, Evan. This is Alec. Great talk. I appreciate mapping stuff of all types. The last time I did any georeferencing was in like 2014 or something. I worked with ArcGIS, and we were just mapping some like research done on wetlands in Nebraska. They had some maps, but not necessarily had any spatial data. What does the procedure look like today? I'm really interested in has anything changed in the past 6 years, or is it made more effective or anything like that?
Oh, not really. So sorry about that. Not really. I think there are some tools. It depends on how strong your lines are. There are some tools that can extract shapes. And so, I played around with a couple of those, but ultimately found it to be more annoying to correct a million things than to just sit down and trace some of the things we're working on. So there are, increasingly, the kind of automated tools there. And I do actually think there is one that is in R that is sort of a combination of basically it takes a first guess at your boundary if the thing's simple enough, or you can basically train it right on a couple little areas, and then it goes out and identifies it. But for sort of a side project like this, that level of tooling is not as useful. There are in my day job, I work with folks who do a lot of machine learning on spatial imagery, and so there's a lot more, right? So building capture and boundary identification is like a whole practice, and you'll have a lot of folks who go in and label 500 different medical clinics and schools and institutions, and then try to train a model to pull those out and pull just those shapes out of all the different imagery you might see. So there's certainly, like, on the high end, more sophisticated tools coming, but they tend to be not the type of thing I'd pull for this, given that I'm probably just going to do one data set, need to get it from some sort of raster image into a vector image just one time.
Yeah. Thank you.
So maybe I'll take the question in the chat from, did you find any particularly good repositories for environmental data? Yes, I think, data.gov allows you to search across different agencies in the US. And so you'll find different environmental data from the Coast Guard, for example, or you'll find it from EPA, as you might expect. You'll find it from other folks. And so, yeah, that's largely where I'd start. I know a relatively obvious a place. And then, increasingly for Cleveland, I do think like the folks at the Cuyahoga County JS are really, really great. And I think that they do a great job of trying to get new data sets on. And I would encourage kind of community engagement, those folks, about what are priorities, what would make a difference for the problems you're working on, the communities you're trying to support and map. And I do think there's probably more data behind the scenes in Cleveland on environmental data than is out there in the public sector. So not to go too deep on that, but I think it's worthwhile asking around, asking if there may be data sets released, et cetera. And you can build on that.
Along those lines, I was wondering if you had any tips and tricks that you picked up with ArcGIS and how best to navigate and move through their interface. I don't know. I'm not familiar if they have an API at all, actually. So,
Yeah, so I actually for this, I've definitely used Arc in other roles before. Used QGIS for this, which is actually kind of great. Like it's an open source project, so it has its all of its little foibles, but is pretty powerful and has some great plugins for a couple different Python geospatial tools. And so is nice because if you get tired of pointing and clicking or you can't remember the interface, there is a command line kind of within QGIS, and then you can kind of save at least myself the mental hassle of trying to remember exactly what submenu something is on. Otherwise, I found QGIS is just and ArcGIS are just creatures of habit. Like you get used to where things are by repeatedly doing them, and you almost I think it was like you're teaching yourself a syntax, but it's a syntax of like moving around menus as opposed to a syntax of like writing code or understanding like what a function component is. I think that can be useful, but it ultimately gets a little limited, right? Because without being able to write that into code and tell the computer to run it programmatically, you're kind of going to have to keep doing it every time. And that's where like QGIS being a little more open source, ability to interact with some of those Python tools in that toolkit can allow you to kind of code things up a little bit. And that's it's really relatively useful. I definitely think about that. Cool. I see Summit County GIS department is also online now, which is awesome. So I definitely agree there should need to be a GIS conference in Northeast Ohio. That'd be awesome. Maybe, not to, I don't want to make it seem like I'm ragging on ARC or Esri at all. I will say their platform, which, I see here the Summit County folks are using for open sourcing data is really great. It's one of my favorite kind of Esri tools. As opposed to the tool for manipulating. I think they've done a really nice job of creating a platform that's easy to use and straightforward for people who are both releasing data sets and trying to manage all the data sets they might release, and then folks who are trying to access it. So every time I ran into something where I came across like an ARC platform for open sourcing data, say it's a state level or city or a county, that's always that's always a great moment when you realize it's going to be straightforward to get the data out of that system.
So was there a particular map you really, really wanted to make, but the data just wasn't there or you just couldn't get it conveniently enough?
Yeah, what do we really want to make? It's a good question. I mean, I think there were maps where we ended up making like short of the map I wanted to make. So I think the opioid map, we had to use a really small period of time because there was very limited data, right? And this is something that really transformed the landscape of Cleveland. Life expectancy went down, because of opioid related deaths and really, sort of the dual crises sort of before COVID, right? Where the housing crisis and then this opioid crisis. And that's one where we ended up putting it in because it was so important, but I don't feel the maps there really like told the whole story or like they kind of got to the point, but then they just kind of brushed by. And I think if we'd been able to get more health data, that would have been really exciting. And I think there were, we ran up into that all the time with health related data sets. So we know there's tons of health inequities across Cleveland, lead rates, et cetera. Like in almost everything, you can figure out some health inequity. And there, I definitely wanted to tell the story of in context of Cleveland being, this sort of incredible city when it comes to having access because that was really hard to even start because there isn't much data available on that topic. And would love to see more. And I think, I will also just put a small plug in. I've often found that for governments, the work you go through for open sourcing something like this once a benefit. So right now we do a lot of COVID response work in my day job. And I find that agencies and folks who did deal with the opioid crisis and built data infrastructure during that are so much better at manipulating data and working on data when it comes to responding to COVID, because they really put in the time to put in some connections to understand with their legal teams how they can move data around, et cetera. And so it always, makes me feel sad when I don't see an open data set for a problem of interest, because it's both, a problem for us when we want to make maps and charts, but it also, in my mind, speaks to some likely concerns about the underlying ability to analyze data. And so, open sourcing is really kind of the proof positive that you have the data, you can do it, you can understand what it is, you can understand what value it might have for someone else. And so, yeah, if I had to say one push, it's really, how can we get more health data openly available so that we can work on it.
Okay, last chance for questions. Okay, well, thank you very much, Evan. That was a great talk, and thanks for all the great questions, everyone.